Hello, Mr. Burrell here. We're in the final stages of this first unit that we're all doing online. How exciting. So this whole unit has been on factoring quadratics. So what I'm going to do is I'm going to go through some sample problems, going through each of the steps that we've talked about so far, each of the lessons concerning factoring quadratic expressions, starting right at the beginning with factoring the greatest common factor. So right at the beginning, we practiced factoring out a greatest common factor, which meant I'm taking out what's in common between all three of these terms. So what I'm going to do is I'm going to factor out each of these terms here so I can find and recognize what each of those terms has in common. So here, this is 10 times 2, and then 5 times 2. This, I think, is 104 times 2, then 52 times 2, and then 26 times 2, and then 13 times 2. It's a lot. 80 is 40 times 2, and then 20 times 2, and then 10 times 2, and then 5 times 2. You might break down those factor trees different, but you should get the same factors at the very end as everybody else, no matter how you do it. So here I got 5 times 2 times 2 times x times x. Whoop. Here I got 13 times 2 times 2 times 2 times 2. 13 times 2 times 2 times 2 times 2. Yep. And then times x. And here I have 5 times 2 times 2 times 2 times 2. 5 times 2 times 2 times 2 times 2. Okay. My next challenge is to identify what terms are in common between all three of these terms here. Between these three terms, what are the factors I have in common? Well, I have a 2 that's in common in all three of these. I have another 2 that's in common in all three of these. And that's it. There's nothing else in common in all three of these terms. So 2 times 2, I can take a 4 out of all three of these terms. Now that I take 4 out of all three of those terms, what do I have left? Well, here I have 5x squared. Here I have 13 times 2, which is 26, times 2, which is 52x. So I minus 52x, because I had a minus here. When I go plus, 5 times 2 times 2 is 20. So that was the first unit, or the first concept in this unit. The first lesson was factoring out a greatest common factor. So for those questions, right here, I'm done. That's all I needed to do. Next, we talked about preparing to factor and just straight up into factoring quadratics. 9.2, 9.3, and 9.4 were all centered around tools to help us factor quadratics. Notice the first tool in factoring quadratics, the first step is to factor out a greatest common factor, which I did already. So now in units 9.2 through 9.4, now I finish this problem and finish factoring this quadratic equation. Number 1, I've already taken out the greatest common factor. Step number 2, if this is ax squared plus bx plus c, I multiply a and c together. 5 times 20 is 100. And I need to find two numbers that multiply to make 100 and add to b, or to negative 52. So that was what we did in section 2. We practiced finding two numbers that would multiply to make 100 and add to negative 52 with a variety of different numbers. So let's find factors of 100. There's 1 and 100. There's 2 and 50. There's 4 and 25. There's 5 and 20. 6, no. 7, no. 8, no. 9, no. And then 10 and 10. And again, you can use a calculator. Pick a selection of numbers. Maybe 100 divided by 2 works and you get 50. 100 divided by 3 doesn't work. You'll get a decimal. So you can try 100 divided by 4 and you'll get 25. 100 divided by 5 and you'll get 20, etc., 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 until you find all the factors that you can. In addition to those, I have negative 1 times negative 100, negative 2 times negative 50, negative 4 times negative 25, negative 5 times negative 20, and negative 10 times negative 10. Those are all the factors, all the pairs of numbers that would multiply to make positive 100 here. Now I need to determine which of those pairs add up to negative 52. Well, negative 2 plus negative 50, that adds up to negative 52. So those are the factors that I'm using, -2 and -50. So remember, the next step in factoring quadratics is I write my factors in parentheses like this. X minus 2 over a, which in this case is 5, and then x minus 50 over a. So I write my factors like this. X plus the factor, so in this case x minus 2 and x minus 50, and then those factors are divided by this a value right here. I had to multiply over here, now I'm dividing. So next step is I have to reduce any fractions that I can. 2/5 I can't reduce, so I'm just going to leave that as 2/5. 50/5 I can reduce, because 50 divided by 5 is 10. So now I've reduced my fractions. My next step is bottoms up. Anything that's left in the bottom of those fractions, I have to write up in front of the x, bottoms up. So I write that as 5x minus 2 times x minus 10. And is that my final answer? Am I done? Wait a minute. The last step is, remember, if I took out a greatest common factor at the beginning, I have to write that back down here. 4 times 5x minus 2 times x minus 10. You notice if you multiply all that together, if you do the rainbow method here and then multiply everything by 4, you will get 20x squared minus 208x plus 80. So that's basically everything we've talked about in this unit from step 1 to step 4. All the way through, every single concept leads up to this point and for this purpose. Okay, let's look at another one. 7x squared minus 22x plus 3. Is there a greatest common factor? So I'm going to write this as the only number I can break out, 11 and 2. So I have 7 times x, 11 times 2 times x, and 3. There's nothing in common in any of those, so I can't take out a greatest common factor. Next step, I have to take a times c, which is 21, and c, find two numbers that multiply to make 21 and will add up to b, or negative 22. So let's find some factors. We have 21 and 1. I have 7 and 3. And that's it. I also have negative 21 and negative 1, and negative 7 and negative 3. So which of those pairs of numbers add up to negative 22? That one. Right there, negative 21 minus 1 is negative 22. So now that I found my factors, I'm going to write x minus 21 and x minus 1. And each of these numbers are divided by 7. Then I have to simplify any fractions that I can. 21 divided by 7 is 3. 1 divided by 7, I can't simplify that at all, so I leave it there. Next step is bottoms up. Anything that's still in the bottom, I move up in front of the x. So I have x minus 3 times 7x minus 1. Last step was if I had a greatest common factor, I needed to put it back out in front of here, but I don't have a greatest common factor, so my final answer is x minus 3 times 7x minus 1. Let's double check, just make sure we did that right. I'm going to do my rainbow here. X times 7x is 7x squared. X times negative 1 is negative x. Negative 3 times 7x is negative 21x. And negative 3 times negative 1 is a positive 3. Combine like terms, I get 7x squared minus 22x plus 3. And indeed, that's what I started with, so I know I must have factored that correctly. Remember, when we're factoring these quadratics, we're basically just taking it from standard form back into the form it would have been before I multiplied them together. Okay, let's do one more. At 4x squared minus 9. So keep in mind that this is 4x squared plus 0x minus 9. There's no x term, so there's just 0 of those. Is there a greatest common factor? No, there is not. So next, I need to find factors of a times c. So 4 times negative 9 is negative 36. So I'm trying to find two numbers that multiply to make 36 that add up to 0. Well, I have 36 and negative 1. I have 18 and negative 2. I have 12 and negative 3. I have 9 and negative 4. And then I have 6 and negative 6. I'm not going to write the other sets of those factors because right here I can see 6 plus negative 6 is 0. So I'm going to write my factors like this. X plus 6, x minus 6, and then both of these numbers have to be divided by a, which is 4. Next step, can I reduce those fractions? Well, 6/4 reduces to 3/2. 2 goes into both of those terms. So I can write this as x plus 3/2 times x minus 3/2. Well then, now that I've reduced my fractions, it's bottoms up. And I write these as 2x plus 3 times 2x minus 3. And if you multiply those back together, you'll notice that indeed you get 4x squared minus 9. And those are the problems that I wanted to go over with you. Remember, factoring quadratics is all about recognizing structure, looking at an expression and being able to notice how it's set up and use that to be able to set it up in a different way. In this case, in its factored version. When we're talking about factoring quadratics, I mentioned this in a previous video. We're going to use this method to help us to solve lots of real-world types of problems. So the next unit that we discuss is all about solving problems that can be modeled with a quadratic expression. Things like throwing something off a cliff or throwing something into the air, launching a rocket, hitting a baseball, shooting a basketball. All those types of things are problems and situations that we can model with quadratic expressions. So I hope that was helpful. I hope you enjoyed it as much as I did.